So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and to ask their doubts or queries related to any project that they are doing or RCC steel design concept or construction site issue that they may be having. So, this is the 48th such episode that we are conducting. And let us begin by taking queries. So first we will start with the queries that have been put in the Google form, and then we will take the queries from live comments. So the first query that has been asked is, while designing the foundation in safe, this query is by engineer Shaddesh Shirode, and he is a postgraduate student. So he's asking, while designing foundations in safe, which model should we export from ETABS, ULS or SLS model? So see, short answer will be that you take the SLS model, okay? But then what happens is that if specifically you are doing a tall buildings project, okay? If you are doing a tall building project, and then in the tall building project, if you have applied wind loads and seismic loads, uh, oh, my screen is not shared. Wait a minute. Yeah, is it now visible? So this question, first query we are taking, and this query is by engineer Shraddhesh. He is a postgraduate student from Nashik. He is asking, while designing the foundations in SAFE, which model from ETABS should we take? The ULS model or the SLS model? So short answer is you take the SLS model and then check for the bearing pressure, etc. Uh, Now the long detailed answer for this would be that it depends that if you are specifically doing tall building project in accordance with, let's say, IS 16700, then what might you have done is that the wind loads that you might have taken for it, this I am giving in specific response to a project that is a tall building project done in accordance with 16700. So then what will happen, the wind loads that you have considered in the SLS model will be for a 20 years return period, because you want to find out the drifts and everything. While in the ULS model, the wind speeds will be for a 50 years return period. Okay. Also, the base shear will be in the I would say base shear for response spectrum. In the SLS model, it will be, you're not required to scale it up, so it will be unscaled. And in the ULS model, you would have scaled it. So in such cases, if you are doing this kind of a project, especially I'm talking about the tall buildings project, then what you should do is you take the, because the wind speeds that you have applied are corresponding to a 20 years return period in the SLS model, because you just wanted to check the drift, let's say, and you have applied a 50 years return period in the ULS, also because the base shear is scaled in the ULS. So what you do is you take the ULS model to save for foundation design. Okay. So short answer would have been, if it was not a tall building, if it was a normal building where where the wind loads, you had not separately applied wind load, let's say for a 20-year return period, or if you had not followed the specific requirements, you could have taken the SLS model also. But the in the tall buildings, you should take the ULS model due to these reasons. See, normal structures, as of now in the IS 456, there are no modifiers also that have been mentioned, right? So IS 456, as of now, the draft is out, but as of now, the 2000 version even does not give you any modifiers to be applied. So as of now, you have a SLS and ULS. There is no differentiation in these two models. There is only one model right now that we have. Okay. But if you are following the provisions of 16700, then the discussions changes slightly. So I think this is how you should deal with it. So this was Engineer Shaddesh. He has put another query that I'll just take up. Uh, just give me a minute. Next query is by. Okay, next query is also by Engineer Shaddesh, and he's asking, based on the image provided, how do we decide whether the wall, how much it should be cracked? Okay, so I think he's asking how to decide the modifiers based on. Just hold on. So based on the image provided, how do we decide in the wall that how much it should be cracked? Is there any provision given for how to decide it? So in the see the modifiers that you have to take, modifiers for wall, there is no provision as such for different modifiers on the basis of cracking. There is no such provision in the IS code, but in the ACI code they have a provision where they have given different set of modifiers for the cracked section and uncracked section. Okay, so in the ACI 318, you have different sets of modifiers, different set of modifiers for cracked and uncracked. So if your wall, and this is especially for RCC structural wall. So if your wall is cracked, then you have a specific set of modifiers. If your wall is uncracked, then you have a different set of modifiers. So in the Indian standard as such, we don't have it, but in the ACI standard, they have given this kind of a modifier. And in walls, then you could, so in the local axis, let's say if this is 1, 2, 3 is out of plane. So generally the modifiers you would like to give will be F22. So F22 will be basically help you to get the in plane moment. So you should give the moment modifier to F22. F11 and F33 will give you the shear modifier. So you could put a shear modifier value over here. And then M11, M22 will be in plane moments. So you could put the moment modifiers over here. So in this manner, the cracking of wall, you could see. So basically, you will have to first check whether your wall has cracked or not by seeing the moment that you are getting and comparing it with the MCR or the cracked moment of resistance value, and then decide the value of the modifier. And as I told you, F22 value you should give corresponding to the moment modifier. F11, F33 you give corresponding to shear modifiers, and M11, M22 you give again corresponding to moment modifiers. Okay. Then he had another question, Engineer Shradesh. He had another question. No, so these were the two questions he had asked. The next question has been asked by Engineer Manish Parmar. He is a practicing engineer from Dehradun, and he has asked these doubts. Let me just put over here. So doubt one, how to calculate the required LD of anchor bolts inside the pedestal So see, if your pedestal is subjected to, or if your base plate is subjected to compression, the forces in the anchor bolts, we assume, if it's a compression in the, let's say this was a steel column and this was your pedestal, these were your anchor bolts, and this steel column is subjected to compression, let's say pure compression, then the compression forces, how do they get transferred? What is our assumption behind it? What is the assumption? Tell me. For compression force transfer, we assume that the transfer will take place through bearing. So our assumption is that no forces will be transferred to, let's say, anchor bolts, and most of them will be transferred through bearing between the base plate and the concrete pedestal. So how to calculate the required length of anchor bolt for this? So I mean, you could just do the calculation as per the bond length criteria given. Although, as I told you, in this case, if it's a pure compression case, anchor bolts will not be subjected to any forces, is our assumption. But still, you could provide the bond length for anchor bolts in compression similar to the bond length calculations that we do for reinforcements. So technically, it comes out to around 18 to 20 times the dia of the bolt. Okay, so generally speaking, in pure compression, you could do the same calculations as we do for development length for reinforcement. The condition under pure compression, the length of bolt around 18 to 20 times bar dia shall be sufficient. Okay. If it's a case of tension or shear, if your bolts are subjected to tension or shear, then it's a different matter. Then you have to do a lot of checks. So those checks you have to do if your bolt is subjected to, is in tension or shear, then there are different checks that you have to perform. So ACI, I don't. Does anyone remember the Indian code for it, which does the checking for anchor bolts? Because I am not able to recall. Yes, anyone in the live audience? Anchor bolt check. I mean, Indian standard for checking or designing of anchor bolts. Anyone in the live audience knows the code number for it? Okay, so I'll just give you the American context. So in the American context, you have this ACI chapter 17, ACI 318 chapter 17. So if you go to that, they have given you different failures of anchor bolts in tension and shear. So you have to check the requirements of bolts, and then different procedures are given how to do the checkings. If your anchor bolt is in tension, the possible failures are in pull out, or in breakout, or in splitting failure, or side face blowout. So all these failures are possible when the bolt is in shear tension. So you will have to do the calculations, find out the required length as per all these limit states, and in shear, uh, prying failure of shear, breakout failure. So all these failures are given if your anchor bolt is in shear. So these checks have to be given. These checks have to be performed. Mr. In-depth is informing IS 5624. Oh, nice. Is the code for checking of anchor bolts or foundation bolts. So does it give the only the specification, or does it give the design process? I think it only gives the specification. I'm not sure, you just check 5624. I guess it only gives you the specification, not the design process. This ACI chapter 17 that I'm talking about, it gives you the checks for different actions in the bolts, especially important when they are in tension or shear. Mr. Prakar Mishra is saying generally IS 800 clause 7. Okay, good. So this was his first query, Mr. Manish Parmar. His second question is how to calculate wind pressure coefficient CP for pitched roof of unclad building. So if your building is unclad from the sides, that is, but you have a sheeting on the top, can it be calculated as per table 9 is what he is asking. So let us see what table we have to use. If it's an unclad building, open structure, that means, and unclad from the sides, that is. So I think table 5, table 6 you may not be able to use because it says table 5 and table 6 of IS 875 part 3 2015, they are valid for clad buildings is what I remember. Let me just go to table 5, table 6. Yeah, of rectangular clad buildings. So 5 is for walls, 6 is for roofs, but it has to be a rectangular clad building. So for open type of structures, what he's saying, yeah, you may refer to the table 9, which is for freestanding roofs. And in that, you will get your shape. So I guess, yes, you could use table 9 for it. Yeah, I do agree. Then his next question is brief or elaborate discussion on design procedures of fasteners. So see, fasteners means where you are connecting your purlins to sheeting. Oh, sorry, sheeting to purlin. So if this was a sheet, basically you will put fastener screws. Now those screws can be self-tapping, okay, or in some conditions you put a J bolt. You may put a J bolt like this. These days, uh, these days, I don't know if you have heard about it. These days, you have the standing seam type of sheets. Okay, so what happens in standing seam type of sheets is that the connection is slightly different between the uh, sheet and the purlin. So it's a different type of connection that they prepare. In the normal sheets where you have corrugated sheets in panels, then either you can go for self tapping or J bolts. The design will remain the same basically. So design procedures will remain the same as we do, but no designer performs it actually, because what happens that when we are given the specification or when we are given the spacings, we have a general idea at what spacing and at what distance we have to, and of what dia we have to provide these screws. So generally you will see the engineers not performing design for it, but yeah, it should be done. The design should be carried out for these fasteners, but generally you will see engineers not doing it. The procedure for design will remain the same. You will have to work out how much force is getting transferred on these fasteners. How can you work that out? From the tributary area contributing to that force, and you can do the calculations for wind, find out the wind force that will be transferred, because wind is the critical for these fasteners, and then see what dia you need to have, how much threading you need to have, how much deep inside it should go in the purlin or your member. So these types of calculations you have to do, but generally you will see engineers not doing it because the spacing that we usually provide is sufficient to take the expected wind forces. But yeah, I do agree that design should be performed for critical actions. Actually, engineers do perform it for critical structures. So yeah, in depth is saying that 5624 was specification of cast in anchors. Yeah, I also thought that it is specification. It is not covering the design detailing process. Okay, moving ahead. Next query is by engineer Nihal. He is a working professional from Kerala and he is asking, I am designing a building with two basements with uplift. I am designing a building with two basements in an area with what I think he has shared some image also on WhatsApp. Let me just see. Just hold on. Who had asked this? Nihal. So he had put one image also. Okay, no, he has not put any image. Anyway, so let us look at this question. I'm designing a building with two basements. So let's say this is his NGL, and then he has got two basements. So this is basement one, and this is basement two, and then he's saying water water table is almost up to ground level. Oh, so water table is right till here. Let's say, what are the factors that need to be considered during the design and construction stage? There will be an uplift of 6 meters because let's say he is assuming around 3 meters for each basement. So almost 6-meter uplift will be there. How do we counteract this during initial stages of construction without the building self weight? And he is using pile foundation. So see, if you are using piles in your raft, assuming you are providing a basement which is having raft with pile, so first of all you can just see that what is the reduction, make that reduction, first reduction to be made in pile capacity, both in tension and compression. So you'll have to make that reduction in the pile capacity when pile is inundated, or let's say pile is under water. So that discussion we had in the last episode, if you remember, uh, where Mr. Vineet had pointed this out, that in the IS 2911 part 1 section, no, part 3, they have given this table 1 where they have given you the pile capacities, and then there is a clause given which gives you the applicable reduction in case of water table. So first of all, make that reduction. The second thing is that let's say when you cast basement 2, now as soon as you cast basement 2 and the other structure is not built, naturally what will happen, that there will be an uplift acting. Now you find out that uplift by multiplying the uh, buoyancy force. Buoyancy force will be approximately, let's say, 6 meters into 10 kilonewton per meter cube density. So around 60 kilonewton per meter square is the water pressure acting. You multiply it by the plan area of your basement, you will get the total tension force. You divide it by the number of piles that you have provided, or total uplift. Now the total uplift, once you get, you divide it by the number of piles, and you will get the approximate tension in one pile. Now just see first of all that whether your pile is sufficient to take that much tension. Okay, so you check that whether your pile is sufficient to take that tension. If it is not, then it's a problem. So if it is not, it's a problem. Now you have to think about it, that how you are going to take care of this uplift. So now Mr. Magaj has provided some interesting What happened? Yeah, Mr. Magaj has provided some interesting options. So he's saying provide pressure release valve. So what does this mean basically? What do we do during construction in such cases that we might think of leaving deliberately leaving some punctures in my basement slab? So I have left some puncture openings deliberately. Why so? This is to ensure that, let's say, when the slab has been cast, after that, if your water table is trying to apply pressure, it will easily get this safety wall sort of thing and it will just fill up your basement. You understand my point? So deliberately you have left these openings to allow the water to come in, thereby releasing the pressure, and it will just uh, occupy that space. Your basement will be filled with water, yes, but then during construction anyway you do not need that basement to be used, right? So this is one of the way, and then you can pump that water out. You do the dewatering when required. This can be one of the options. Next option could be, if you don't want to do this, you may think of filling this up. So as soon as your basement is cast, you may fill this up with soil or muram, let's say. But of course, this is a problematic way because filling is not so easy, and then you have to somehow remove it also. So filling this up with muram or soil may not be the best scenario in this case, at least. Another option could be that, what can be another option? One of the options could be that you can create some subsystem below the basement just to take the water out and give the water a path to, let's say, come from here, and then some sort of mechanism to pump it out. Okay, so you just like we had provided an opening in the raft, a basement raft, not similar to that, but the concept remains the same, that we are trying to release the raft from the water pressure. So we have created some channels, okay, and those channels are connected to some pipes, let's say, and that can be connected to some motoring arrangement. So deliberately we want that this water should percolate and just come inside this channel, and from there we can pump it out. So this can be another option. In this type of a case, easiest and most doable option is to provide some openings in the basement raft and allow the water to come inside, let it fill it up, and then pump it out when your dead load increases due to construction of other floors. Okay. Mr. Magaji is saying pile will resist some sort of uplift. Compare both uplift pressure due to water and uplift. Correct. So your piles are also going to resist some uplift forces. So you need to provide this arrangement for the balance only. Okay. Yeah. Very nice. So this was Engineer Nihal. Provide anchors also. This Mr. Magaj is suggesting. This means in the basement itself provide some anchors. But I think this, because your strata is such that you are giving piling, anchors may not be a good solution in this, because of the strata that you are providing. Sorry, because since you are providing piles, I'm assuming the strata is such that anchoring may not give you a good enough uplift capacity. Okay. Okay, good. So these can be a few of the possible solutions you can think of. Moving ahead, this was Engineer Nihal. Now, engineer, this question is has been asked by Engineer Tarun Bharadwaj. He is from Delhi and he is a working professional. So he is saying, how is the rapid growth of artificial intelligence expected to reshape the structural engineering job market over the next 20 years? I don't know. Anyone in the live audience would like to give their thoughts on this? And which skills will be most critical to avoid large scale job losses? I'm not most certain about it. So, anyone in the live audience would like to give their views on these two questions? Yes. The question that has been asked is, how is the rapid growth of artificial intelligence expected to reshape the structural engineering job market over the next 20 years? So, any thoughts, live audience, please? So, nobody in the live audience also has any thoughts on this. So I really don't know how AI will impact, only time will tell us. But at present, maybe you could learn how to make some custom GPTs. Okay, so making small tools which will help your work or assist in your work. Some small calculators that you can make in the form of custom GPTs. That is one thing that you could think of doing. Uh, Mr. In-depth is saying it will make your job easier. Till date only planning means, till date only planning means, I did not understand. Yeah, so I was thinking maybe uh, doing some vibe coding, which means that not even if you don't know basics of coding, I also don't know anything about coding a lot, but then llms using the llms you could come up with some coding which can you can execute, and it will help you in uh, preparing some tools which otherwise you could not do it on your own because you did not know coding, and those tools will simplify your work. So that can be one of the ways in which you can try to learn these things. Okay, Mr. In-depth was saying that it will make our jobs easier because it will assist you in your work and all those things. Anyway, so I don't have much thoughts about this. So, yeah, that was Engineer Tarun Bharadwaj with his question. Now, next query has been asked by uh, Engineer Nikhil. He is from Bengaluru, working professional from Bengaluru. So he is asking, kindly explain the procedure for carrying out axial shortening of columns in ETABS. So in our course on tall buildings, we have covered this topic in great detail over 5 6 sessions. So I may not be in a position to tell you everything in such a short time, but then you first of all, for calculating the axial shortening, you need to know the material uh, time dependent properties. This you should be able to calculate this material time dependent properties. Now generally this is done with the help of some models means with the help of some documents or codes. So there is this FEB CIP, I think, code. There is this ACI 209R. So depending on your material grade, depending on the reinforcement ratio, uh, depending on the water cement, a lot of aggregate content and a lot of such things, you are able to calculate the material dependent time properties. Time dependent material properties, and then from those properties, you input it in ETABS. Okay, then you have to do the construction stage analysis. So in that, you have to work out, or you have to define the construction stages with their times, and then you have to use that modify and deform geometry option in ETABS. and then you will be able to do the axial shortening calculations. Okay, so there are these things that you will have to involve in your calculations for doing the for doing the axial shortening. See, this axial shortening generally is not critical for a 200 meter or even a 300. I mean, for a 100-150 meter building, axial shortening is not such a big issue. Okay, when you go beyond 300 meters, 350 meters, 400 meters, then axial shortening will start to get critical. Otherwise, in 150 200 meter, that means in 40-50 story buildings or even 60-story buildings, axial shortening might not be such a critical issue. So using ETABS, using the time dependent properties, material properties, then doing the construction stage analysis, modify and deform geometry options, you will get the uh, axial shortening, and then you will have to strategize that at which level you want to give how much axial shortening. I mean, you have to give an extra column casting at which level, how to incorporate that in your construction drawing. All those things then you will have to strategize based on the axial shortening calculations that you do. Okay, all right. Next question has been asked by engineer Abhijit Sathe. He is from Pune and he is a working professional. He is asking, while designing friction pile, kindly explain. Oh, sorry, this question. His question is, while designing a friction pile, is it to be checked for dishing moment? I'm not sure what is dishing moment. What is dishing moment? Anyone in the audience? In fact, I'm hearing this term for the first time. Dishing moment while designing friction pile. Anyone is aware of this term? Let me search for this term. Dishing moment. Oh, okay. I think dishing moment has been defined by the moment, the lateral, the moment caused due to lateral loads in the pile. Okay, okay. All right. So what is this question? While designing the friction pile, yeah, you should check for the moments also. You should check for the moment also, bending moment also. If yes, for which axial load? No, no. See, for axial load, and so if your this is your pile and this is your NGL level, whatever FFL or NGL, whatever it is. First of all, you will calculate the depth of fixity. Okay, from the depth of fixity calculations, you will be able to calculate the bending moment in the pile for lateral load. So whatever is the lateral load, depending on the depth of fixity calculations, you will get the bending moment in the pile. Also for the vertical load, due to the minimum eccentricity, you will have to calculate the minimum eccentricity moment in the pile as well. And then accordingly, I mean, if the minimum eccentricity moment in the pile is more, then you take that. If the bending moment due to lateral load is more, then you take that, and then you include that moment for your calculation purpose. Okay, so you have to do it, and it's a usual practice to incorporate it. Understood? Okay, so this was engineer Abhijit Sathe. Mr. Magaj is saying fixed debt and free head movement will be taken as per condition along with axial load. Correct. So movements that will be calculated in this manner will be considered while you are calculating or checking the cross section of your pile and when you are finding out the reinforcement in the pile. Next question is Mr. Vineet Kabadi is asking how to design basement wall. Considered there are three basement wall, each of height 4.3 meters. So, see, I difficult to explain it in a short session like this, but you could do it using. I mean, first you will have to apply the loads on your basement wall, find out the moments, check for cracking, all those things you will have to do. Check for flexure, check for shear. These topics we have actually covered in different courses. Like I think in tall buildings course we have covered this topic in great detail. Similarly, in the liquid retaining structures, we have covered this topic in great detail, because basement wall is nothing but a wall which is retaining or which is resisting lateral loads. So in these two courses, we have covered these topics in great detail. So you might be interested in having a look at those courses. Uh, but yeah, it is difficult to explain the entire process in such a short time. If you have any specific doubt related to it, you may ask. Next question is from Engineer Tosh Agrawal. He is a working professional from Raipur. He is asking how to provide brickwork in PEV shed up to 3 meter height and how to arrange clear to flush with brickwork. So generally, whenever we are providing brick walls, there are a couple of things in which we can do. Let's say this is the plan view and this is your steel column, and let's say this is your pedestal or this was your base plate. Are you able to see the image? Now, one of the possible ways is why. So this is my base plate. This is my column. Now, one of the possible ways to have a brick wall is that what do? We have a concrete pedestal that we take outside. So what I have done here, I am maintaining, let's say, a 50 gap or a 100 gap, and then what I do is on this side I am giving a 200 gap. Assume. Similarly, over here also, I am giving the same. That on this side, I am deliberately giving a larger gap. Now, after doing this, I will have my brick wall placed outside of the steel column. So my brick wall is not interfering, or it's not in the same plane as my steel column. Do you understand? This can be one of the ways. So in section, how it will look like that I have this as my steel column. In sectional elevation, and this is my base plate. Then I have my RCC pedestal, and then I'm taking the brick wall which is outside. So brick wall is not touching the steel column in any manner. Now what is the advantage of having this kind of an arrangement? Tell me, what is the advantage of having this kind of an arrangement? So the advantage of having this kind of an arrangement will be that if there is no integration between the PEB column and the brick wall, so whatever wind loads etc. are acting, they are not going to affect your brick wall. I mean, whatever brick wind loads are acting on your PEB shed or PEB columns, they will not affect in any manner the brick wall. Okay. Otherwise, what happens sometimes is we had faced this issue in one of our projects also, where the brick wall was, so this was my shed, let's say, this was the eaves level, and till 3 meters we had provided a brick wall, and above that was sheeting, and this brick wall we had provided touching to the steel column. So what happened when wind loads acted upon the deformation of this PB shed will be slightly more than the brick wall, of course. So the PEB shed deflection was more than the brick wall deflection. So we could see some vertical cracks that got developed in the brick wall. So then it was a problem and all those things. So generally what we do is we try to keep the brick wall free from the PEB column. Don't have it connected. Now if it is your situation, if it's your requirement that no, you have to have the brick wall flush with the columns, then what you can do is that, let us say this is your steel column. Now I'm showing you another picture, and this was my base plate for it. And suppose due to certain requirements you cannot take the brick wall outside, you have to take it inside itself. In such a case, what you can do is you have a pedestal over here, let's say, and what you do is that you have a concrete mullion column cast over here separately, and you have your brick wall like this, and maybe you could continue with this, but I have introduced this mullion column. So this portion of the brick wall, and of course there will be a ground beam or whatever below. So this portion of brick wall is just connected with the mullion column, and then this small brick wall you can construct it later on. So let's say even if cracking, lagging, etc. has to happen, it will happen on these small little portions. You will not see any significant issues with the main wall. So what I have done, I have isolated my main brick wall by providing mullion columns on either side. So this can be one of the options you could think of. Okay. So generally speaking, this type of arrangement is desired or preferred, where I am keeping the brick wall free and in no way connected to my steel columns. Yes. So this was engineer Tosh with his query. He has another query where he is asking why to provide bracing in bottom chord of truss. Yeah, that is one of the reasons why you provide the bracing in the bottom chord. What he is asking is, suppose I have a shed, and I will just try to show you the elevation. Suppose this is my elevation and this is my gable end, and I had a wind column over here, and then of course there is rafter at the back also. So what will happen on this gable side when the wind forces hit? It may cause movements in the rafter about the minor axis. So there is a possibility that because of the wind forces acting, there might be a movement in the minor axis that is caused in the rafter. So when this is the case, then it becomes problem. So for this, generally what we assume is, as Mr. Tosh is rightly saying, we may provide bottom bracings connected to the next rafter system. So from the gable to the next rafter, we might provide some bottom some bottom bracings. So this is one of the ways to counteract, and whatever wind force is acting, we are safely transferring it through axial forces, thereby reducing the possibility of movements in my rafter. This is one of the ways. Or sometimes design engineers also assume that because there is a purlin that we are providing over here, that will take care of this wind force. But I think providing a bracing in the bottom of the rafter is the best way of tackling it. Okay. Yes. So I do agree with your statement that bracings on the bottom side or bottom chord or bottom face of the rafter will help you to resist this wind force that is acting on the wind column. Okay. Then the next query is has been asked by Engineer Prakhar Mishra. He is from Delhi. He is a working professional, and what he is saying: kindly explain the lab splices clause this given in IS 456, especially for tension bars 1 and 2. Where are tension bars 1 and 2? I think he had shared one image also. So let me see the image. Okay, he has not shared any image. He has actually shared the codal image, the screenshot of the codal provision. So what is the code saying? Actually, he had asked this question earlier, but I could not read the codal provision. So let me see. Lab splices is the codal provision for lab splices shall not be used for bars larger than this. Lab splices shall be considered as staggered. Lab splices, including anchorage of hooks for bars of flexural tension, shall be LD. Lap length, including anchorage value of hooks for bars in flexural tension, shall be LD or 30 times bar dia, whichever is greater, and for direct tension shall be 2 LD or 30 dia, whichever is greater. The straight length of the lap splice shall not be less than 15 times bar dia or 200 mm. Okay, so I think what is being said over here is that let's say I have a beam. Lap splices, lap length including anchorage value of hooks. So if I'm not sure if this is my bar and then there is another bar and I have provided a lapping over here. So lap length including the anchorage value of hooks for bars in flexural tension shall be LD or 30 times bar dia. Let's say I don't have any hook right now, so I will have to provide a 30 times bar dia or LD as my length. If I had hook, then I could take the hook length also in this LD or 35 requirement, out of which 15 times bar die or 200 had to be the straight lap length over here. Right now in our case we have not provided any hooks, etc. So we have to ensure that the straight lap length has to be LD or 30 dia. When lap occurs for a tension bar located, okay, so when the bar is in tension, so here it said in flexural tension, and here it is saying for tension. So I guess, although I'm not sure, I'm just reading the clause for the first time with you. I think here they are referring to bars in pure tension. I think, is it so? Because at in the earlier line they had written flexural tension, and here they are saying tension. So I'm assuming it has to be in pure tension. So if that is the case, let's read and try to understand. Where lap occurs for a tension bar located at top section, top of a section as cast, and the minimum cover is less than twice the dia of lapped bar, the lap length shall be increased by a factor of 1.4. I'm not very sure about it, but let's say there was a bar over here, top of a section. What is meaning of top of a section? And the minimum cover. So this cover, if it is less than 2 times the bar dia of the bar, then this lap length that we were providing, which was LD or 30 times bar dia, it has to be multiplied by 1.4 times. Corner of a section and minimum cover to either face is less than twice the dia, then also 1.4. No, I will have to read this. I need to read this properly because, as such, with first reading, I'm not able to get a lot of things over here. So I do need to read it. Where lap occurs for a tension bar. So first line, this should be. We should try to understand that this tension bar is it due to flexural tension or axial tension. That I first need to understand. I need to read this more before I'm able to answer this. Yeah. So more in-depth reading I require before I can answer. So maybe in the next episode we'll try to take this up. Okay. Then the next question is, I'm just checking if whether I have not accidentally left anything. The next question is by Engineer Rakesh Kumar. He is from New Delhi and an independent consultant. If a building height is greater than 45 meters, do we need to take temperature loads in the layout combination for footing design or can we skip it? See, for the footings, because they are below ground, you can skip the temperature load requirement because below ground we are assuming that the temperature will not play a part. So temperature will play a part in superstructure, not in the substructure. So generally you need not consider temperature loads for footing design. And generally what do we do is wherever we are providing double columns and here let's say we are leaving a gap to cater for temperature effects, then in even in these cases we start these two columns which are separated by a gap from the same footing. So footing remains the same. From this footing itself I will take out two columns. So below ground I am not very worried about the temperature effects, so you can ignore the temperature effects for foundation calculations. Okay. Next question is from engineer Umang Patel. He is a postgraduate student and he is writing from Nashik and he is doing his thesis in IS ductile design of steel structures based on IS 18168 code. What he is writing, I think he is talking about the expected strength analysis. He has shared some image in the WhatsApp group. Where is WhatsApp? Wait a minute. So this is the image of the model that he has shared, and then he has also shared the screenshot of the codal provision. So he's talking about how to carry out the expected strength analysis for the SCBFs. So in our course on ductile design detailing of steel structures and also our course on AISC steel design, we have covered these issues. So what is he saying? To apply clause 12.2.2.2, we can create a copy of the model, assign non-frame property to the bracings, and apply frame point load in the bracings. Now, what will happen when we assign a none property? I'm not sure what will happen. In ETABS, actually, you have this option of, in the course, we did not discuss it, but in the ETABS, you have the option of tension compression limits for frame members. In the course, we did not discuss it because I came to know of this feature later on. So, what you can do is that in the ETABS, there is this option for tension compression limits. So, you can set up, let's say, these are your bracings. So, for these bracings, you can individually give the tension and compression limits and then run a nonlinear analysis considering some loads, some lateral loads, and then you will get the tension and the compression that you have set up in your TC limits. So generally what we will do is that if we are doing this, so here the analysis in which all the braces are assumed to resist forces corresponding to their expected strength in compression or in tension. So you will calculate the expected strength of bracing in tension, in compression, assign them as tension and compression limits uh, using the ETABS option. In the second scenario, you will assign in the tension bracings, you will assign the tension limit equal to their expected strength in tension, and in compression, a value equal to their post buckling strength in compression. So this you can do. So I'm not sure which method you are proposing over here, but in ETABS with the use of tension compression limits, it's quite easily, you can do it this thing quite easily. Okay. Yes. Okay. So this was Engineer Umang Patel with his no. This was Engineer Umang Patel with his query. Now, so these were the queries that had been put in the Google form. Now let us take the questions from the live audience. So in the live audience, if you have any queries or questions, now you can ask them. So Mr. Magaj is asking, what is the design approach for a temple pyramid? What is temple pyramid? Temple pyramid in RCC. What is a temple pyramid? I'm not sure. In the live audience, Mr. Manish Parmar is asking, if possible, kindly put some light on table 9 as per 875 part 3. How to use pressure coefficient from it. So I'll give some documents where you can have a look at the ways in which you can use these pressure coefficients looking at table 9. So first of all, if your sheeting is if your roof is fully covered, this is my table 9. If your roof is completely covered with sheeting, your solidity ratio will be 1. Your solidity ratio will be 1. And then depending on your roof angle, you can calculate this wind value. So roof angles are given over here. For all values of phi, they have given, and these are the coefficients given to you. Okay. So using this, you could do the calculation. And then they have given you these values also for phi equal to 0 and phi equal to 1. So phi equal to 0 means completely open. In our case, we shall take phi equal to 1. So for example, your roof angle will be this positive roof angle. Okay, positive roof angle. So whatever is your positive roof angle, let's say it is plus 5. So this coefficient overall is given as 0.3. And then over here, let's say plus 5. For phi equal to 1, it is given minus 0.9. Oh, it is plus 0.3. What is this? Wait a minute. What is given over here? Roof angle, all values of phi. So our phi is 1. So for plus 5, it is given plus 0.3 overall coefficient. And if I were to look from here, it is given minus 0.9. So I think you will have to take this value. My roof angle was plus 5. Solidity ratio is 1. You will have to take this as your wind coefficient Cp. Okay, yes. Okay, got it. So see, in this case, it will be, in this case, Here you were given plus CP and minus CP both. I guess here you have to take, I think here also two cases you will have to take. These are all the positive values given. So maybe once you will have to take a plus 0.3 as the coefficient, and towards the roof you will have to consider, and once for the roof angle, once you will have to consider the away coefficient of 0.9. So I guess you need to make two cases. In one, all the positive coefficients are given over here, that means acting towards the roof. So for a plus 5 degree roof angle, you take the plus 0.3 coefficient and accordingly consider it, and then make one more case over here for roof angle of plus 5, for a phi of 1, coefficient is minus 0.9 away, so you take that also. So make two separate cases and consider it. Okay. Then uh, Mr. Rakesh Kumar is asking, if a 98-meter long building has no expansion joint, do we need to include temperature load combinations when designing isolated foundations? And should maximum and minimum soil pressure be checked in safe? See, my opinion is for temperature loads, you consider the temperature loads and load combinations in the superstructure. You don't have to separately consider the temperature loads for your foundation design. You consider them for your superstructure, and automatically that will be included. And when you bring those reactions, maybe those reactions you can include for foundation design. But I guess, yeah, you could do it this way. But then, okay, so you are saying you are not providing any expansion joints, or okay, yeah, so you could do it this way, that you do check for temperature and you bring the temperature reactions or the outputs for temperature to safe and design the footing for it. So in the footing, you don't have to consider any temperature separately. You just bring it from ETABS and or whatever software you're using, and design your footing for that temperature reactions also. Mr. Magaj is clarifying that it is a cone shaped structure, gumbad, in a pyramid shape. No, so I'm not very sure how to do it. You will have to send the proper sketches and send the proper shape, then we will be able to do it. Next query is from in depth. He is asking, is it always required to multiply 1.2 for the member forces for connection design as per Indian code IS 800, or is it done for SMRF frames? So if you are referring to chapter 12, don't refer to chapter 12 now. Chapter 12 will give you those requirements. So don't refer to chapter 12 of IS 800 now, because it has been superseded by 18168, which again will be superseded by an upcoming code IS 13920 some part. I don't remember the part number. So do not refer to chapter 12, refer to this. They have given you appropriate procedures for connection design for whichever system you have incorporated. I mean, for whichever lateral load resisting system you have, which you are using, you can appropriately consider the connection design for it. So in our course, we have done a separate course on design and detailing of earthquake resistant steel structures based on 18168. So probably you could have a look at that course also. Mr. Umang Patel has provided this image and he is saying, okay, so his question was whether we should remove that bracing from the model. His question was that while doing the expected strength analysis, Are we required to remove these braces and point loads to be assigned? I'm not sure about it. I'm not sure about it because what I had seen in some of the AISC documentations, they had not done it this way. Uh, they had just applied or ensured a force to be applied in a manner in which the bracings get to their required tension or compression forces, and then they take the forces in the beams or columns, corresponding forces in beams and columns, and design it accordingly. So I'm not sure about this. If the member has to be removed and then you apply nodal forces, I'm not sure. Mr. Magaj has shared one image. So this is the image that he is having, and he is saying cone shape structure. So I don't know, for maybe for this shape you may have to create some three-dimensional geometry and figure out how much of forces are getting transferred on these arches. Okay, so I don't know how to manually at least do manual calculations for it. I'm not sure right now. Generally, a lot of the forces will be transferred as an arch action to this, but how much of it, I'm not sure at this point. Maybe you can try making some three-dimensional geometry of this from this shape that has been given. You try to make a three-dimensional model and then see how the stresses are getting distributed, what are the forces in this arches, etc. So right now I don't have a very good answer for it. Okay, so these were the queries that have been asked for this week, and we have taken all the queries. Okay, we have one more query from engineer Parth Pandya. Okay, he had put this query in the WhatsApp also. So he is a working professional from Ahmedabad. Let us see what he is asking. In the building, center core wall is considered the lateral load resisting system. No, it is not considered the lateral load resisting system. It is part of it. But having central core walls, as we had discussed in our tall buildings course, also leads to other issues like in-plant torsion and all those things. So, although lateral load resistance is provided by the central core wall, but it's not a very good place to have these walls because it adds to the torsion. Anyway, so he is saying that the central core wall is provided as a LLRS and all other periphery columns are gravity columns. So we have considered R factor of 4. Also, is it necessary to provide well distributed walls in both directions? Yes. Well distributed walls should be in both directions. If the 2% requirement is not sufficient, what alternate should we consider? What is the 2% requirement? 2% of the plan area, is that the requirement? Let me check the 16700. I think this 2% that he is saying, this was the requirement of well distributed walls. No, 25% it said. What is this 2%? I think it is 25%. 2%, I'm not sure right now. What is this 2% requirement? Anyway, so assuming that he has provided core walls in the center and he has taken or assumed all the columns on the periphery to be gravity columns and taken R factor of 4. I think it is for dual frames or what, I am not sure. This R factor of 4 is for dual systems. But if it is a dual system, I don't think it satisfies your question requirement. Or maybe this is the structural shear wall system for which R is being taken as 4. So yeah, you could do this, but then uh, it has to be well distributed. If it's only a central core wall, if you understand, you are not adding redundancy to the system. So overall, the system is not very good because all your lateral load resisting systems are only in the center, and all your peripheral elements are gravity resisting elements. So I would say, in principle, it's not a very good system to have. Mr. Parth is saying, as per 1893 2016. Mr. Magaj is saying it is 2.5% plant density. Is there any such rule given? No, it is 25%. I don't think 2.5%. Yeah, it's a 25% clause. So, see, my opinion of this is that this is not a very good system. This does not look to be a very good system. That if you have all the lateral load resisting elements only in the center and all the peripheral systems are columns, uh, prima facie, it's not a very good system to have because this does not offer you any redundancy. That if there was a, and see, number one is central cores do not work well in resisting lateral loads. Okay, central core walls will not be very helpful in resisting the lateral loads. Also, because then you will have to introduce some elements to transfer the loads to the central core wall. So again, if that is the case, this column you cannot leave it as a gravity column. It has to take some effects of the movements also, the earthquake movements also. So I am not very convinced with the type of system you are proposing. Okay, if at all you want to give only centralized cores, you have this system as an SMRF at least. So have this as an SMRF and have this as a central core wall. This is okay, but just having gravity columns uh, on the periphery and centralized core walls is not a very good system. Okay, Mr. Pankaj is saying yes, it is given 2.5% requirement for walls. Now, what is the clause says? I'm not sure about the clause. Anyway, short answer for your question is that this system does not look to be very good. You have centralized core walls, but then you have a perimeter SMRF. Don't go for a perimeter gravity columns. No. Okay. All right. So I think these were the queries that were asked, and we have taken up all the questions asked on the Google form and also on the live comments. So that's all for this session then. We will see you next week. The link for Google form remains the same. So throughout the week, you can paste your queries over here. And once every week when we meet, we will take up your doubts during this session. So I'll just put that link for Google form. And if you want to connect with us on WhatsApp, you can message using this link. I'll just put that link over here. So in case you want to connect with us on WhatsApp, you can message over here. you can message by clicking this link. So I think that's all for we have for this week. We'll see you in the next episode now. Thank you everyone for joining, and yeah, that's it for this week then. Bye bye.